So in this question, I denote the definite integral here. The value of I is to be found using two different methods. Show that the substitution u equals root x minus 1 transforms I to this integral, and hence find the exact value of I. Part 2, A. Simplify this, 2 plus root x minus 1 times 2 minus root x minus 1. And part B, by first multiplying the numerator and denominator of this integrand by 2 minus root x minus 1, find the exact value of I. So there's the problem then. I've got it summarized here. Let's get stuck into it straight away then, shall we? Part 1, let's use this substitution. So this is the square root of x minus 1. So that tells us then when x is equal to 2, the lower bound, here, let's find out what u should be. 2 minus 1 square rooted is 1 square rooted, which is just 1. And x equals 5. U is equal to, the upper bound is 5. Put it in here, 5 minus 1 is 4. 4 square rooted, root 4 is 2. So there's our bounds then between 1 and 2. Now we need u du, don't we? Du dx. So it's something to the half, so it's a half, something to the minus a half when we differentiate, multiplied by the something differentiated, which is 1. So that's equal to 1 over 2, and this can drop down and be that to the half, which is u. So it's 1 over 2u. So that tells us then, move the dx up to be here, read from right to left, and move the 2u up to be with the du. 2u du. So let's try and write down the integral then. So here, I is equal to the integral between 1 and 2 now, rather than 2 and 5, isn't it? 1 and 2, of the 5 minus x, so it's 5 minus x. Now we need x, don't we? Let's get it from here. So let's just square both sides. U squared is equal to this squared is x minus 1 then. And that tells us that x, reading from right to left, move the 1 over, is u squared plus 1. So we're going to put that in here, u squared plus 1 du over, and what did we have underneath? 2 plus root x minus 1. So that would be 2 plus u. The du, I just decided to write that down, but it's dx still, isn't it? And we need to replace dx by 2u du. So all of that on the top times 2u du, and this underneath, of course. This is 2 plus u here, because it's a square root of x minus 1, wasn't it? So we've just been a little bit double checking there we needed to do, just to iron out any little glitches that we might have made. So what have we got on top then? We've got 5 minus 1 is 4, so we've got 4 minus u squared over 2 plus u times 2u, the integral of between 1 and 2 du, which is equal to the integral of 4 minus u is the difference between two squares, so it's 2 minus u, 2 plus u, isn't it? Times by the 2u du, all over 2 plus u. And we can now see that when we factorize this quadratic, the difference between two squares, the 2 plus u's cancel top and bottom. So we're simply left with the integral of, between 1 and 2, of 4u, and then minus 4u squared, is minus 2u squared rather. Minus u times 2u is minus 2u squared du. That equals, it's going to be 4u squared raised to the power divided by that number, minus 2u raised to the power divided by that number. We need to evaluate that definite integral between 1 and 2. So that equals then, this is just 2, isn't it, here, 2u squared. So put 2 in here, 2 squared is 4, 2 times 4 is 8, minus, and then put 2 in here, 2 cubed is 8, so it's minus 16 over 3. Take away the bottom value, put 1 in here, so we just end up with 2 times 1, which is 2, minus, put 1 in here, 2/3. So we get 8 minus 2 is 6, And then we get minus 16 over 3 plus, when we run the minus through, 2/3 is minus 14 over 3. 18/3 is 6, take 14/3 is 4/3. Okay, so that's the first part done then. Let's move on to the second approach now. Let's simplify this then, part A. So it's 2 plus root x minus 1 times by 2 minus root x minus 1 is equal to, it's a difference between two squares, so it will simply be 4 minus the first term squared and then the last one squared, isn't it? These two squared. Plus and a minus is a minus. It's the object squared, which is square rooted, so we just get left with what's inside, the x minus 1. Run the minus through now, we get 5 minus x, which is what we had on top. So now we can do the integral. This is part B. I is equal to 5 minus x can be replaced by this. Dx, and underneath we had a 2 plus root x minus 1, didn't we? Dx. Okay, good. So, and that was between 2 and 5. So now these are common factors now on top and bottom, so we can cancel them. We simply integrate this. So let's do that then. So that's equal to 2x minus, and then this integrates to something to the 3 over 2. Just raise the power by 1. Now when we differentiate this, the 3 over 2 comes down this to the half, which is what we want, multiplied by the something differentiated, which is 1. We don't want 3 over 2, we just want 1 lot of, so we need to get rid of that by putting 2/3. So now let's just double check that. 3 over 2 comes down, with this making 1 lot of, this to the half, multiplied by the something differentiated, which is 1. And we've also got a minus there as well, of course. So that's fine, and we've double checked it between 2 and 5 now. So let's work that out then. So what do we get? 5 in here, 10, minus 5 in here, 5 minus 1 is 4, 4 to the half is 2, and 2 cubed is 8. So this number's 8, so it's minus 16 over the 3, minus bracket, put 2 in, 4, put 2 in here, 2 minus 1 is 1, 1/20 power is 1, so it's just minus the 2/3 then, isn't it? Close bracket, so we've got 10 minus 4 is 6, minus 16/3 plus, when you run the minus through 2/3 is minus 14/3, which is what we had above. 18/3 take 14/3 then is 4/3.